In this video, we're going to see how red tides, which are events that happen at human timescales, and we can observe them nowadays, with biozones and other concepts of biostratigraphy. This is a video that shows a red tide that happened in 2019 in the Algarve, so the southern coast of Portugal. So the clear blue waters were apparently tainted with red. And this happened for a couple of days and weeks, and it was caused by a specific group of algae that belong to the microplankton Dinoflagellates, and a specific type of Dinoflagellate that we are going to see. So the beaches were closed, fishing was not allowed for a couple of weeks, because these Dinoflagellates produce some toxins which are harmful for marine life and also for humans in case they ingest these fish or shellfish. So the extent of this red tide was quite large. So there's a scale here. Almost the whole coast of the Algarve was under red alert, and also part of the coast here along the Alentejo coast. So we're talking about an event that had an extension of a few hundred kilometers, so it's quite significant. And probably not just the coastal areas, but open sea as well was affected by this. In the western margin of Portugal, there was no reporting of this event, so this was probably just restricted to this area. At least significant amounts of this Dinoflagellate were only recorded in the southern part of the country. This was due to very high water temperatures that were ideal environmental conditions for the massive reproduction of this Dinoflagellate. So in a couple of days, the numbers were up to a few millions per liter of water. This was the Dinoflagellate that caused this red tide. It's quite small, so just under 50 microns. And this has this red color, and hence the red tide that it can cause. So although it's very small, if you have millions of them in a liter of water, then of course you're going to have a problem. And indeed, it can be a huge problem for marine life. So kind of a reconstruction of what happened in the Algarve coast. So you had the sea with the normal marine microplankton. In a section view, the different geological layers contain different microfossil associations, and these will basically represent the microplankton that was living in a water column when these several layers were deposited. So each layer will contain a different fossil association. During the red tide, this specific Dinoflagellate, which usually exists it's part of the marine microplankton in the Algarve coast, but because the environmental conditions were optimal for its reproduction, it boomed, so it's called also an algal bloom. So in a few hours, it became dominant species in the microplankton, and eventually all of this will go down into the sea bottom, and it will be preserved as another sedimentary layer. So the microfossil association assemblage that will be characteristic of this interval will be the abundance of this specific Dinoflagellate. You may find a few other microfossils which were also present in the water column, but the main characteristic of this bed will be precisely the abundance of this Dinoflagellate. So Dinoflagellates are unicellular flagellate protists. They will have at least one, usually more than one flagellum, and hence the name, which allows them to move around in a water column. They produce a very resistant organic wall during their life cycle. It's quite complex, but during a specific stage they will form a cyst, which can continue its life cycle, but many of them will fall to the sea bottom and they will be preserved as fossils. All of them are aquatic, most of them are marine, although some live in brackish waters or freshwater environments. So they range from the mid-Triassic to the present day, so since 245 million years, more or less. There are few occurrences which may be older records of dinoflagellates, but it's unclear if they are truly dinoflagellates or other algal groups. They are very useful for biostratigraphy of marine sediments because they are relatively abundant, their morphology is quite diversified, and they appeared and disappeared over geological time quite rapidly. So each interval, short interval of strata and corresponding geological time will have characteristic dinoflagellate fossils. So they can be used to determine sedimentation ages. They can also be used to characterize polyenvironments, so to know if we're seeing a rock deposited in a coastal marine environment, in an estuary, or more open marine, and so forth. The biozones, which are based on the occurrence of fossils, in this case specifically microfossils, marine microplankton, are mostly based on the first and last appearances of specific taxa. So there are different types of biozones, but most of them are based on that, either a single taxon or a group of taxa that define a biozone. There's one specific type of biozones, these abundance or acme zones, which are based on a significant abundance of a specific taxa during a short time period. So that they will be based not on the appearance or disappearance over a geological section, stratigraphic section, but on the abundance of a taxa or small group of taxa during within a strata or a small group of beds. So these abundance zones, they are the body of strata in which the abundance of a particular taxon or specified group of taxa is significantly greater than is usual in the adjacent parts of the section. So the taxon will be present below and above that specific interval, but there will be this interval where the beds will be characterized by the significant abundance of that taxon. So unusual abundance of a taxon or taxa in the stratigraphic record may result from a number of processes that are of local extent. So this is important to capture, that these are not usually global events. You have these peaks of abundance which are usually restricted to a sedimentary basin, as we saw in the Algarve and parts of the Alentejo, but not the whole continent, not the whole margin, and even not extending, for example, to Morocco or to Spain. So because it has a local or maybe regional relevance, it may be difficult to correlate laterally, so it should only be used at the scale of a basin. The boundaries of an abundance zone are defined by the biohorizons across which there is a notable change in the abundance of the specified taxon or taxa that characterizes the zone. So it will be these points here. So from this sample upwards, we'll start seeing a lot of these specimens of these species, and then at the end it will go back to its normal abundance. So it will be present below and above, but at a specific interval it will be very, very abundant. So how does this relate to red tides? If you remember this reconstruction, then this specific bed that deposited during the red tide will be characterized by the high abundance of this dinoflagellates. So if you transform this into a geological section, a stratigraphic section, each strata, each bed will have a characteristic fossil assemblage. Some of these, this for example, will stop here, but it will be present in some strata, and others will be very rare or it will not be present. Others will be present the whole section. There's a few others that will be present from this point onwards, and a few others which will be very rare and they'll be present only in a few strata. But then this in particular, it will be present throughout, maybe a bit rare or a bit more common, but there's a specific interval where it will be dominant over all the other taxa. So this abundance can be used to define an acme zone, an abundance zone, which will have the name of the dinoflagellate that characterizes this interval. So this is how red tides, which are processes that we see happening at human scale, so weeks, days, can actually relate to geological processes which are usually observable at scale of millions of years. And they do get recorded in the geological records, and they are observed at the local scale and can be used as stratigraphic markers for regional correlation. I leave you with an invitation to visit our website for more interesting videos on biostratigraphy, petroleum geology, and also on our activities, services, and training activities.